Hey everyone, I hope you had a great time in EDD.NET and welcome to developing serverless application with ASP.NET Blazor on AWS. But before I get started, let me quickly introduce myself. My name is Pradeep Bagchi. I'm a senior solution architect with AWS. I'm based out of Toronto and I'm with AWS for a little over 2.5 years. I specialize in application modernization. I work with customers to modernize their enterprise workload and help them to run at scale on AWS platform. I always find interesting to start my session with a question. So let me start the same thing here. How many of you know this page? Though it's a virtual session, I cannot see you, but if you are saying yes, that means you are the folks you believe in long relationship. Congratulations. I'm also on the same boat as you are right now. But the sake of this presentation, let me take you to a quick recap session and let me walk you through how ASP.NET evolved over the period of time. Before .NET Core, or as we know .NET, came into life, ASP.NET web applications can only run on Windows operating system and under the full .NET framework. And there are many things that you can do with ASP.NET. You can develop web apps using different UI models. You can create a web API that serves data as well as you can implement real-time capabilities using ASP.NET SignalR. ASP.NET Web Forms was the first web UI model that was introduced in the release of .NET Framework 1.0 back in 2002. And a few years after that, web forms became popular and we had ASP.NET MVC as a new alternative model for building web applications. Bringing MVC into .NET actually opened up for a wider audience of developers, just like me, as it values a clean separations of concerns. It has a friendly URL routing, allow deeper extensibilities and follows real web development experience. ASP.NET also provides built-in templates for building single-page applications such as Knockout.js, React.js, AngularJS, etc. And when ASP.NET Core was introduced, a lot of things were changed in a better way, though I'll not spend much time to tell you about ASP.NET Core because I'm pretty sure you are hearing throughout these 2 days of sessions. But since the framework was redesigned to be modular and unified and especially cross-platform, a lot of enterprise developers and architects started leveraging ASP.NET Core to build a cross-platform application. And Blazor is the latest addition to the ASP.NET Core framework that's based on single-page application. You can think of it as like a React, Angular, or Vue, or any other SPA-based framework, but it is powered by C# and Razor View Engine. And you don't need to write any web application code with JavaScript to run it on the client side. You can rely on C# as well as you can embed C# code within Razor View Engine. Blazor WebAssembly is a single-page application framework, as I mentioned in my previous slide, for building interactive client-side web apps with .NET and C#. It uses Open Web Standard without any plugins or recompiling your code into any other languages. WebAssembly is a compact bytecode format, and the reason it is like that is so that it can be downloaded in a faster way, and you can also get the maximum execution speed. Blazor can run your client-side C# code directly in the browser using WebAssembly. So that's the beauty of Blazor right there. And your modern web framework for .NET, which is ASP.NET Core, has everything that you need to have to build rich modern web user interface and a powerful backend services. The addition of Blazor to ASP.NET Core extends the reach of your web application to the client side. And there is no need to rewrite your ASP.NET Core apps to use Blazor. Blazor components can be directly added to your existing MVC views as well as Razor pages. Blazor can run your client-side C# directly in the browser in the WebAssembly. Now, probably you are thinking why Pradeep is talking about Blazor, ASP.NET, and giving the recap of all the .NET evolution that happened in last 10 or 15 years. The primary reason for that is AWS loves .NET. I love .NET and you love .NET. So there is so much love here. So definitely we should dive deep into how you can use Blazor, ASP.NET Blazor framework to develop a single page application in a serverless way using AWS Lambda. AWS Lambda is a serverless event-driven compute services that can let you run your code without provisioning any hardware, without managing any instances, without managing any compute resources, so that you can focus on the application development rather than infrastructure management. You can trigger Lambda functions over 200 plus AWS services. That means you can integrate your Lambda function with wide range of AWS services and also interact with different AWS services for different business requirements. Benefits of serverless compute and AWS Lambda comes down to 4 key things. First, you do not have to think about any server management. No physical, no virtual, no containers. You do not have to think about anything related to operating system, compute resources, patch management when it comes to serverless and AWS Lambda. Secondly, it scales with your usage. As the requests come in, we are going to scale with the request. Thirdly, you do not have to pay for the idle time. Most of the enterprises are already paying for resources when they're sitting idle, which as per public case studies around 80% of the time, which is significant amount in investment for you and your customer. With serverless, you pay for the usage and you pay as you go. And the last and most important thing, application running on serverless platform automatically leverages the benefits of regions and the availability zone that we have to have a built-in availability and the fault tolerance for your application. Here in AWS, we call it small pieces loosely joined. And there is a book by the same name, by the way. But this context, we are talking about a loosely coupled event-driven architecture using services like AWS Lambda, API Gateway, and S3. And we will be using all of these services in our demo today. But along with that, there are other supporting services that you can leverage, like DynamoDB, step functions, event bridges, etc., to create a really loosely coupled, highly cohesive application architecture. Lambda functions can be invoked either synchronously or asynchronously, depending on the trigger. For the synchronous invocation, the caller waits for the function to complete the execution, and the function can also return a value. Synchronous invocations are best fit for a short-lived Lambda function, and we will be using synchronous invocation for our demo. But on the contrary, asynchronous operations are best fit where caller does not expect a response from the function. The caller places the event on an internal queue, which is then processed by another Lambda function. There is a third invocation, which is under the hood. Synchronous invocation is event source mapping, where you integrate with a specific event sources. Before I talk about how to deploy and package a serverless application, let me also briefly talk about Amazon API Gateway. Amazon API Gateway is a serverless service that makes it easy for the developer to create, maintain, monitor, publish, and secure API at any scale. API Gateway acts as a front door of your application to access data, business logic, functionalities of your backend services. Amazon API Gateway consists of three main parts. Number one is the integration. Since the API Gateway is not the final destination, it's just the front door of your application, the integration piece is what your client is really trying to do. The second piece is the request flow, which contains everything before the HTTP request hits the backing integration, and it's concerned with the validating and preparing your request for the integration. And the third one is the response flow, which contains everything after HTTP request hits your integration and deals with preparing the response to the client. But last but not the least, I also have to talk about AWS SAM, which again we'll be using for the demo, which is serverless application model. But before I talk about SAM, let me do a public confession here on this platform. It is my personal opinion, this is the best service icon by far that we have compared to any other service icon. I love this little fella. The serverless application model uses a simplified CloudFormation template or CloudFormation syntax to define a serverless application that comprises of resources of functions, API, DynamoDB table if you need for your Lambda project, and it also allows you to easily define their event sources. It provides an easy way to define environmental variables and allow you to embed multiple functions in a single template. And of course, being CloudFormation, you can embed any other resources that you need in the same template. Basically, it's a CloudFormation template. Now you know about API Gateway, AWS Lambda, AWS SAM template. Now the question is, what are we building today? We will be building a web application, serverless web application that will let you download and save a YouTube video to a S3 bucket. The backend of the web application will be building using AWS Lambda and API Gateway, and the front end will be building together using ASP.NET Blazor. We'll be hosting the front end inside a S3 bucket and will be accessing the website via a CloudFront URL. CloudFront is a content delivery services powered by AWS that lets you to access static content in a fast and secure way from an edge locations. So without further delay, let's get to the development and let's build it together. The source code of this application is located under AWS samples project in github.com. The source code has everything that you need to create your backend, which is the API Gateway and the AWS Lambda. It also has the Swagger file that we will be using to deploy the API Gateway. And it also has a separate CloudFormation template, which we'll be using to deploy the CloudFront, which is the content delivery network. And that CloudFront will be used to access the front end. So everything we have it together as far as backend is concerned in a public project under github.com. So you can access it whenever you want to after this session is over. So let me clone the Git repository that I was showing you in the previous slide. I have a folder in my PC where I have just downloaded the Git repository, and it's a Visual Studio solution. It has the Swagger file, it has the template that we'll be using to create the package, the deployment package using SAM. I'll just keep a separate command line open in this particular location, so I'll be using it later. But let me open the Visual Studio solution to show you and walk you through what the solution is and what are the things are inside. And this is the solution we'll be using to create the backend. That's primarily consists of two things. One is the API gateway, and that is the API Lambda. It takes a couple of seconds to load. I think it's loaded. Now it has a function .cs file, which is the entry point of the Lambda. So I have a function handler which takes the input, which is the video request, and returns the output, which is the video response to the API gateway. And now the video request file has three properties. One is the URL, bucket name, and the video title. And the response has two things, status code and the message. So when I'll call the API, it should return me the status code and message depending on the success or failure. Now I am going to create 3 ST buckets for 3 different use cases. One is to hold the deployment packages. Another is to deploy the front end. Other one is to save the download, the YouTube download, which is the output of the API. Right now, let me run 3 APIs real quick to create 3 ST buckets so that I don't have to go to console and click and do it. It's going to be faster. Oh, I'm still struggling between Mac and PC. Pardon my CLR and CLS. I do that all the time. I promise eventually I'll get better at it. But let me show you the Swagger file. Swagger is the definition of the API. So I have to change 2 locations here. I need to replace the AWS account number there because I'll be using the role name that is going to get created using the CloudFormation template. So it has to be for the account that I'm picking for the deployment. So I'll copy the account name from the AWS Management Console and paste it in 2 places. One is line number 32 where I'm using the IAM role. Another is the URL for the function invocation, which is the Lambda function. Like I'll tell the API gateway to call the Lambda function when each time someone is calling the API. So I don't have any other place to change anything, but you can see the Swagger file definition. It takes 3 inputs. One is bucket name, title, and the video URL. Let me also open the template file. This template file is nothing but a CloudFormation template. It creates the role name. The role name is created using the least privilege principle. I have only given access to assume role, Lambda, and API gateway, and I given very limited access to S3. And now I'm going to run SAM validate to make sure my template that I have is valid or not. Let me, but before that, I totally forgot that it's a new project. I need to build first and then publish it. So let me quickly build the solution. Looks like I don't have any error, which is a good news, but let me publish. It's going to publish the output in the publish folder. Now I'm going to run SAM validate. Hold on. Okay, sorry, I am running it in the wrong folder. So I need to run it in the same folder where the template is. So let me go to the folder. Now if I run the SAM validate, it should be able to find the Swagger file and the template file. Yeah, looks like it's a valid template. So now I need to package this SAM template, and then I'll deploy it. Yeah, let me copy the folder or the S3 bucket that I created to upload the SAM package that will get deployed to the AWS account that I created. Okay, it should upload my code package to the S3 bucket. Yeah, it's uploaded everything. Now if I run SAM deploy, it's going to create a CloudFormation template internally, and which will show the output on my command line, that how each and individual resource is going to get created, and you can follow along as it is creating those resources in AWS. And at the end of this CloudFormation template, once it is done, if it's run successfully, it should tell me the API endpoint that we need to use in the front-end application to upload the video into the S3 bucket. It takes like a couple of minutes to deploy the API gateway and the Lambda function. Looks like it's done creating the API gateway. There you go. I have the URL that we'll be using, and I have a Postman opened up that I can use to test it. So let me quickly change the URL that I received, and also I need to change the bucket name, the bucket we created for this. Let me also show you the API that has been created. So this is the API has been created from the SAM template. You can see the invocation path is the path taken from Swagger and the execution role taken from Swagger. Okay, let me quickly copy the bucket name where we'll be uploading the video to test it out. So let me send this, fire it up. If everything works fine, I should get a 200 OK response. Okay, I'll keep my finger crossed. Hopefully everything will be okay. Awesome. I got 200 OK response, and I have the MP4 uploaded. Let me also download to make sure that it's uploaded properly and it's playing properly. Nice. Now I have the video uploaded. So my backend is up and running at this point of time. Now we need to develop the front end and club them together with the backend. So next step is the one we'll be doing it for the front end. We'll be creating a Blazor application, and we'll deploy it in the S3 bucket, and we'll be accessing via the cloud front end point. Now, before I actually create this project using Blazor WebAssembly app, I just wanted to tell you a couple of things. Blazor is a web framework for building web UI components, and that can be hosted in two different ways. One, Blazor component can run server-side in ASP.NET Core, and it can also run in the client browser, I mean in the client side in the browser on a WebAssembly based on .NET runtime. Like with the Blazor server hosting model, the app is executed on the server within an ASP.NET Core app. But that's not what we're going to build here today. What we'll be doing today here is we'll be creating a ASP.NET Core Blazor project for the client-side web interface. Like, we'll be running this code in the client browser and we'll be hosting it in the S3 bucket. So we just need to make sure that we are picking the right template. So when you search Blazor at the time of adding new projects, you will see there are two different type of templates available in Visual Studio. One is for the server app, another is for the WebAssembly app. But just need to make sure we are picking the right one. So I'm going to choose Blazor WebAssembly app for this particular demo to move on. Yeah, let me create the project and name something very simple so that I can use it down the line without worrying about too much. So I'll just name it a client. And then I don't need to select HTTPS. And most important thing, we have .NET 6 LTS. Wow, that's great. Let me create the project and it's going to give me everything that I need to run a basic WebAssembly project on ASP.NET Blazor. Let me compile this. First, I need to make this one as a startup project real quick. Let me do that. And let me run as is the way it came to me. Let me see whether it's building or not. I think it should. Awesome. Okay, I have the Hello World template, and from here we can actually see a couple of things we need to change. One is on the left side navigation to have our own download, and the input that you need to pass for the download. So let me first change the left side navigation. So I just need my own download link so that it can point to the page where I can upload all the YouTube URL, bucket name, and the file name. So this is the navigation menu Razor file. Let me quickly paste some HTML that I have already created, created for this particular demo. Okay, cool. So I have the navigation link fixed. Let me what did I do now? Okay, so let me paste it again. Oh, okay, I missed the div. Let me close the div. Now let me create the model class where I'll be holding the properties that we need to pass it along. So let me create a folder here. I'll name it models. And then I'll create a class here which will hold my video request. So if you remember correctly from the Postman collection, we had three properties which we are passing to the API gateway. One is the bucket name and where we need to save the file, and then is the title, the name of the file, and then the URI of the YouTube video. So we'll be adding three properties here: URL, bucket name, and video title. Let me quickly add those properties, and I'll make all of them string to make it very simple for this particular demo. And I'll just copy this bucket name properties and make it a video title. Cool. I think I have everything what I need for the video request. Now I need to create the component. So now I'll be creating the razor component. So component is something that you can reuse within the page. So we'll be creating the download component here. I'll be naming it download because we'll be using it to download YouTube videos. Yeah. And I have previously created the code for this particular component, so I'll just go ahead and reuse it. But I'll walk you through what I'm going to do. It's a very simple code snippet. I'll be copying over here. Yep. Now you can see I have three properties. I'm using the video request model that we have created, and it has three properties: URL, bucket name, and the video title. We are going to map these properties or bind these properties with the input. And how cool is that, right? So I don't need to pass it to a variable or anything else. I can just map it to a property. And then in the code section, I can write my favorite C# code that will take this video request and call the API gateway endpoint. So API gateway endpoint, the same API gateway endpoint we'll be using that we used it in the Postman collection. I'll copy it from the CloudFormation output and just paste it over here. I think I made a quick typo error. Let me quickly go ahead and fix it. So I copied the HTTPS twice. So let me remove it. Yeah, I think now I have the exact same URL that I got it from the CloudFormation, which we are using here. Now let me build. If everything works fine, then I should have will succeeded. Awesome. So everything is good to go. Now I'll go back to the command line where I have to publish this. So let me open a command prompt where I have the client. Okay, so I'm now going to use a folder named web publish to publish this output that will be uploading it to the S3 bucket that we created previously, which was the web hyphen S3 bucket that we have created. So I'll go to this folder where all the output is, and I'll just run an S3 sync so that it can sync all my content with the S3 bucket. Let me quickly run S3 sync here. Now this will sync everything I have on my local folder to the S3 bucket that I've created. Let me double check. Yes, it uploaded everything what I need to upload to the S3 bucket. Next, we'll be creating the CloudFront distribution. So instead of creating through the console manually, we'll be using a CloudFormation template, which I have already provided in the GitHub distribution. And we'll be using that CloudFront template to create the CloudFront endpoint. So I'll go to the CloudFormation console and then I'll upload this template, which I have on my local folder. And then I can use any stack name I want. I'm going to use cf-web-frontend. I think that's gonna match the description, but make sure I'm selecting OAI enabled equal to true because that is the origin access identifier, so that only my CloudFront can access my S3 bucket, and it's going to take some time to create my CloudFront distribution. It takes few minutes to have the CloudFormation to execute everything and have the CloudFront endpoint up and running for this particular demo. But for the sake of this demo, I'll fast forward and then we'll go to the section where the CloudFront is up and running. Let me quickly fast forward this demo. Okay, now looks like my CloudFormation is done execution. So I have the output with the CloudFront endpoint. Wow, my single page application up and running, serving content from S3 bucket via a CloudFront endpoint. So all I need to do is now test it out. So I'm going to use the YouTube URL, the same URL that I have used before. I'll put my bucket name, the one I created for this particular purpose, and I'll just name this video title what's AWS. And let me quickly download the video. It looks like my file uploaded successfully. Let me go and validate it. So if I go to the video S3 bucket, I have the file. Let me download and play and see whether it's exactly the content I want. Save it and let me play it. Wow, I have the same video that I had on YouTube right now available in my S3 bucket. Thank you for staying with me so far. I hope you enjoyed the demo and learned how you can use AWS serverless stacks to develop and deploy ASP.NET Blazor application and run it on the client side using WebAssembly. If you have any questions on ASP.NET Blazor or you want to know more how to modernize your .NET application using AWS platform, feel free to drop me an email on the email ID that I mentioned on the screen. You can also connect with me with LinkedIn. And I hope you enjoy the rest of your enterprise developer day. See you soon.